Okay, hey guys, so this video is going to cover the periodic table practice exam I gave out in class. What I highly suggest for you guys, if you don't have a copy, you could check out Pupil Path. I'll have it uploaded in the email I send out. And if you guys prefer, you could stop the video at any time, try the problems out. In this video, I will be explaining each question one by one and the answers behind the reasoning behind each answer. Okay, and let's start. Okay, so let's start with number 1, where we're looking for an element that can be brittle or soft in the solid phase and is a poor conductor of heat and electricity. So let's highlight some keywords: brittle or soft, and poor conductor of heat and electricity. All of these are traits of a non-metal. So that means we could cross off some of the choices that we know to be metals. So let's say copper, calcium, strontium. So that leaves us with sulfur as our answer. Number 2. Pure silicon is chemically classified as a metalloid because silicon does what? Okay. It's a metalloid, so that means it has both metallic and non-metallic properties. Metalloids are also known as semi-metals, so they're that in-between phase between metals and non-metals. Okay, next we have number 3. Each ground state, in the ground state, each atom of an element has 2 valence electrons. Keyword valence, 2 valence electrons. That means we're looking for something that's in group 2. We could cross off choices 1 and 4. Next, we got to look at something that has a lower first ionization energy than calcium. So that means we need to look for something that's below calcium, further down the table. Calcium is period 4. So that leaves us with period 5 and up. So choice 2, group 2, period 5. That's our answer. Okay, next we're going to look at number 6. I'm just going to skip ahead to the other side. The elements on the periodic table are arranged in order of increasing atomic number. Simple. Number 7. Solid element that is malleable, a good conductor of electricity, and reacts with oxygen is classified as a what? So malleable and good conductor of electricity are traits of being a metal. There we go. Number 8. An atom in the ground state has a stable electron configuration. This atom could be an atom of what? So, stable, keyword, full octet, full valence shell of 8 electrons. So we're looking for a noble gas in group 18. That can't be aluminum, that can't be sodium, so it has to be neon. Okay, number 4, which set of properties is most characteristic of transition elements? Wow, sorry. Transition, the key word is that they are colorful. Next, what kind of oxidation states do they have? Negative or positive? So they're metals. What are they most likely to have? Positive ions. So they're going to have multiple positive oxidation states. They're both colored ions in solution and multiple positive oxidation states. Choice 1. Okay, number 5. When an atom of phosphorus becomes a phosphide ion, the radius what? So phosphorus becomes a negative ion. Now when you have negative ions, that means they're taking in more electrons. They're filling up the shell even more. So they're just going to expand a little bit more. So the radius increases when it becomes that negative ion. Next, we're going to look at number 9, which grouping of circles, when considered in order from the top to bottom, best represents the relative size of the atoms Li, Na, K, and Rb respectively. So we're going to see from top to bottom if they follow the order of their radius, or relative size, sorry. So Li, Na, K, and Rb are part of the same group 1, and going down, they kind of go down in that order, Li, Na, K, and Rb. So as you go on further down the group, you're adding on more energy shells. And so with each energy shell, energy level that you're adding, it gets bigger in size. So when you go down a group, you're increasing the size of the atom. So that's choice 4. 10. The chemical properties of calcium are most similar to the chemical properties of what? So chemical properties is a key word here, and those that are part of the same vertical group on the periodic table share the same chemical property. So calcium is in group 2, so we got to pick another element that's part of that same group. And the choice is choice 4, magnesium, Mg. Number 11, which element requires the least amount of energy to remove the most loosely held electron from a gaseous atom in the ground state? So this refers to the least amount of ionization energy. So you're going to look in Table S. Use Table S to figure out and look up the values for the ionization energy for each of these four elements. And if you do that, you'll find that sodium has the least ionization energy out of these four choices. Okay, number 12, atoms of which element have the greatest tendency to gain electrons? So this refers to a high electronegativity value. And so if you use table S again, you can look for these values and you should choose choice 3, fluorine. That has the highest electronegativity value of 4.0. Now we're going to look at number 13, an atom of aluminum in the ground state and an atom of gallium in the ground state have the same what? So both of these are in the same group, group 13. So those in the same group have the same number of valence electrons. Next, we're going to look at number 14. What is the net charge of an ion that has 8 protons, 9 neutrons, and 10 electrons? So we're going to focus on just the protons and electrons because neutrons are neutral. They have no charge. So we take the sum of them. 8 minus 10, because electrons are negative, you get negative 2 as your net charge. Number 15, in which section of the periodic table are the most active metals located? So the most active, those that really want to react. So that's further down the table, towards the bottom. But then you also want to look towards which side has the metal, so that's towards the left. The most metallic metals are towards the left side of the table. So it's going to be the lower left corner. Next, number 16. Same idea, most reactive metals, so those close to the bottom, choice 4. Most reactive, they want to give it up, so they're going to have a lower ionization energy. Next, we're going to look on the other side for number 18, which list of elements consists of metal, a metalloid, and a non-metal, respectively in that order. So metal's on the left side of the table, metalloids in the middle, close to the zigzag, and a non-metal is towards the right side of the table. If we look at each of our choices, choice 1 is wrong, choice 3 is wrong, choice 4 is wrong, that leaves us with choice 2. There's some debatable ones, those that are kind of on the edge of metal and metalloid, but we're going to go with this. This is the closest we can get. Okay, we're looking at the element UUT, which is number 113 on the periodic table. And number 19 asks for the charge of the nucleus. So the nucleus only consists of the protons and the neutrons. We could ignore the neutrons because they're neutral in charge, and so we focus on the charge of the protons. And so if it's element number 113, there should be 113 protons. So a charge of positive 113. Don't forget that positive sign. It asks for the sign of the charge. And look at that. Don't forget that. Number 20. Identify one element that would be chemically similar to UUT. So chemically similar, that means the same group. That means they're going to have the same number of valence electrons. You could pick any of those elements within that same group. Group 13. Okay, so that means you could have aluminum, you could have gallium, etc. Boron. Any one of those would fit the bill. Number 21. Draw a Lewis dot diagram for an atom of UUT. So the Lewis electron dot diagram only refers to those in the valence shell. So we decide what group it's in, figure out how many valence electrons it has, and just draw that diagram. So there's 3 of them, and just draw them around. UUT, write the symbol, and then you just draw the dots in for 3. Okay, number 17. Which trends appear as the elements in period 3 are considered from left to right? So going from left to right across a period. That means you go from metal to non-metal, so a metallic character decreases. And as you get closer over to the right towards fluorine, electronegativity is going to increase. So here we're looking for metallic character decreasing, as well as an increase in electronegativity, so that has to be choice 4. Next, well, I guess that's it for this page. So I guess we'll just wait for me to finish writing up this section. You know what's something I really want to get back into doing? Restudying Japanese and Russian. You know why? Because I want to, when I meet my favorite athletes from Japan and Russia, I want to be able to speak with them. That's why I learned those languages. Alright, now we're on to the last page where we see a chart with given values of two different groups of atoms. So in 22, we have to explain in terms of electron shells why the radius of a K plus ion is greater than the radius of an Na plus ion. So why? In terms of electron shells. So electron shells refer to the energy levels. And let's compare them. K potassium and Na sodium. Potassium is 1 period lower than Na, so it has one more energy shell. It's also of a greater energy, has more energy levels than sodium. So as a result, if you have more energy shells, then you're going to have a bigger radius. So that's why. Number 23, write both the name and charge of the particle that is gained by an F atom when the atom becomes an F minus ion. So if it becomes an F minus ion, that means it's becoming negative. It gained electrons. So that particle is named an electron, and that sign is negative. Okay, I guess this isn't the last page. This is really the last page. Okay, 24, state the trend in our first ionization energy for the elements in the table as the atomic number increases. So if you check the table, it just decreases. 25, you take those points, plot them as such. So I plot them when you just start from 0 from the bottom. That's what it looks like. 26 wants us to explain in terms of atomic structure why cesium has a lower first ionization energy than rubidium. So cesium. Cesium, I forgot what I wrote. So cesium has more energy shells, energy level shells. So it's easier for electrons to move away because they're very far from the center, those valence electrons. So they're going to be easy to remove from other elements with high electronegativity. So that's why it has a lower first ionization energy. It's bigger in size and those electrons are very far out. So it's easy to take them away. So that brings us to the end of this video. Due to time constraints, I unfortunately won't be able to make the content review video. I'll probably do as best as I can to probably put it out as early as I can, but I apologize if it doesn't get out to you guys as early as possible.